So the last type of example in 8.4 is a real-world application. So use vectors in space. So I'll read the problem. Rockets. After liftoff, a model rocket is headed due north and climbing at an angle of 75 degrees relative to the horizontal at 200 miles per hour. If the wind blows from the northwest at 5 miles per hour, find the vector for the resultant velocity of the rocket relative to the point of liftoff. This is page 513 in your book. The easiest way to solve this problem is to draw the given. So there's a given that the model rocket is headed due north and climbing at angle of 75 degrees. So I will write, so climbing at angle of 75 degrees due north. Due north and relative to the horizontal. So, relative to the horizontal. Next given is 200 miles per hour. Relative to the horizontal at 200 miles. At 200 miles per hour. And the wind blows from the northwest at 5 miles per hour. So, wind blows 5 miles per hour. Where it is? Wind blows from northwest. Wind blows from northwest. Okay, so we're completing the given. We need to find the resultant velocity vectors for the resultant velocity. Let us draw this. 75 degrees due north horizontal at 200 miles per hour. So let's say that this is north, south, west, east. It's just like this. North, south, west, east. 75 due north. So this is north. 75 horizontal. So north, 0, 0, 0. North, 75. There is a line, or this is the given line. 75 degrees due north, relatively up. So this is the 75 degrees. So if I will draw, it's just like this. Okay. So from here until up is 75 degrees. Okay. Next, there's a given statement that 5 miles per hour wind blows from northwest. So this is north, this is west, 5 miles per hour. But it's stated that wind blows. So there's a wind blows from northwest. So it will go to its opposite direction. So the opposite direction is here. This is 5 miles per hour. I will indicate this as 5 miles per hour. Okay. Now let us indicate that I is for point east, J is for point north, and then K is for point up. So I is for east, J is for north, representation, and then K is up. Now, this vector is representing the rocket's velocity, and vector W representing the wind blows. So, let us represent V, the velocity. So, since from this statement, there's no east, so I will indicate is as 0, comma. So, I, J, there's a north. So north is 75 and then this is 200 miles per hour. I will write 200 miles per hour. So north is 75. Then cosine wrong. Magnitude is 200. Magnitude is 200. Cosine 75 degrees. Comma. And then there's up. Up is here. So up is 200. Then sine 75 degrees. Okay, so we're complete. So if we will compute this, V is equals to 0, 200 cosine 75 is 51.8. Approximately 51.8. And then 200 sine 75 is approximately 193.2. So we already represent velocity. Now, let us represent the wind blows. So, let us indicate wind blows as W. So, in wind blows is here. Do you have east? So, yes, we have east here. So, this will become, what is the miles? 5 miles per hour. 5 cosine. What is the angle? The angle is 315. How do you identify the angle? So, where did we get this 315? So, as you can see here, this is north, west, south, and east. So, as this given is 45 degrees. So, if this is 45 degrees in fourth quadrant, 45 degrees in fourth quadrant is 315. Right? 0, 90, 180, 270, and then 360. 360. So, if this is 45 degrees, 360 minus 45 is 315. So, that's the reasons why we have 315 here. Then, comma, do you have north? Is there any given north here? So, of course, yes. So, there's a given north here because it's opposite directions, wind blows. So, this is 5 sine 315, comma. Now, there's no up and down here. So, there is no K. This will become 0. Let us compute. So, W equals, what is 5 cosine 315 is 3.5, comma, what is 5 sine 315 is 48, negative 3.5, negative 3.5, and then 0 is 0. Our task is to find the resultant velocity of the rocket. So, the resultant velocity of the rocket is V plus W. So, V plus W, 0 plus 350, 3.5 is 3.5, comma. 51.8 plus negative 3.5 is 48.3. And last is 193.2 plus 0 is 193.2. So, this is the final answer. If you want to rewrite this in linear combination, this can be written also as 3.5. I is east, so I plus 48.3, J as north, and then plus 193.2 Z up. So, these are the possible answers. It can be written as a vector of comma and then can be written as a linear combinations of ij and z. Or ij and k, sorry, not z. I'll erase this. We indicate up as k.